Hi, I'm Martin Lindsay from the Study and Learning Centre at RMIT University. This is another movie on differentiation. This time we're focusing on limits. The limit of a function, by definition, describes the behaviour of this function in the vicinity of a particular value of the variable, which is usually x. Let's look at the function x squared plus 1 and investigate the limit of this function as it approaches x equals 1. Let's first sketch the function fx equals x squared plus 1. As you can see, it's a parabola y equals x squared, which has been shifted up the y-axis 1 unit. Point of interest here is the point at x equals 1 and y equals 2. And we will refer back to this slide a little later. What we do first of all is to find values of x as it approaches 1 from below. In other words, we're moving from the left-hand side of the graph up to the value of x equals 1. Go back to the previous slide. As we do that, as x approaches 1 from the left or below, the values of the function will approach 2. In other words, as x approaches 1 from below, x squared plus 1 approaches 2. Now let's investigate what happens to x as it approaches 1 from above. In other words, we're moving from the right of the graph to the value of x equals 1. Go back to the slide again to see the red arrows indicating this. When we plug in our values of x as they approach 1 from the right or above, the values of fx approach, as you can see, 2. So as x approaches 1 from above, x squared plus 1 approaches 2. So, in both cases, below 1 and above 1, as x approaches 1, the value of x squared plus 1 approaches 2. So we say more formally that the limit of x squared plus 1 as x approaches 1 is equal to 2. Now let's investigate the limit of a more complicated function. Here the function fx is equal to x squared minus 1 divided by x minus 1. Again, as it approaches x equals 1. Let's investigate this function more closely. Notice that if we let x equals 1, the denominator of this function will be 0. In other words, it's not defined at x equals 1. We say it is not continuous at x equals 1. So if we restrict our function to all values except for x is equal to 1, we can now progress and factorize this function. X squared minus x becomes x brackets x minus 1. Notice that we can cancel terms top and bottom. In other words, the function fx is equal to x. So, sketching the function fx equals x, as you would expect, we have a straight line for all values except for x equals 1. And this is the point at which we will be investigating the limit. In other words, f of 1 does not exist, but as x approaches 1, the value of f of x approaches 1 as well. So, more formally, since f of x is equal to x, then the limit of x squared minus x over x minus 1 as x approaches 1 is equal to 1. Now try some questions for yourself. The answers to these questions are on the next slide. Thank you for watching this short movie.